Okay, let's do another example. All. Okay, so you can, for example, so these are the order, so that that's gonna be like uniform. So delete D and then E and then C. So to make it simple, you can, for example, if they are something like this, yeah, you can just replace that with this. Yeah, so from here to here, they are 4, 1, 2, 3, 4. So you can just delete all the edges, then make one edges and put label 4. Yeah. So that's to make it simple. But careful, when you delete, for example, B, yeah, no, C. For example, if you delete C, then from C, you can, okay, so let's, to make it easier, yeah, just to make it easier, I'm just gonna put some arrow here. This one here. Oh. Otherwise, it's gonna be quite complicated for you. So these are the arrows. So the arrow indicating that you have to go to that direction. Okay. So from D, from this D delta, you cannot go to Charlie. Now again, be careful when you delete B, because you have to like C, because you have to, so be careful, because if you delete B, you have to mention also the how many ways from A to B via B, A to C via B, and also A to D via B. Yeah, so that is this row. You have for that row here, and this from there, but and also this row, that's from A to C via B, but also from A to D because of this row. Yeah, this row. Okay. Now I'm going to ask Inaya Andup. I just want to read the name here, yeah, because I'm not so sure if that's your real name. Inaya? Is Inaya there?
Yes, sir.
Yeah. So from A to C, how many ways? From A to C, how many ways? Via B. A to C via B, how many ways?
Six.
Yeah. So there are 6 ways from here to here. And how many ways from A to D? Kayla Mo Deong?
Yes, sir.
Yeah. From A to D via B, how many ways?
8, sir.
How many ways?
8.
Right. Agnes Victoria, how many ways from A to D via B?
2.
2. Yeah, that's right. Because that's only this one times that. So there are 2 times 1. There are 2. While here, to C, there are 2 times 3. Okay, so you can just replace that. Maybe I just gonna draw another one. So this is deleting B. Then you have from A to C, that is 6. And from A to D, there are 2. And it is 1. And then from here to here, that's the same way. Yeah. So it is so B is gone. Now you have to, we are going to delete D. We are going to delete D. Okay, again, or better note D, yeah? So we have to delete C first. Because why? Because there are some road from here to D, so it's better. Yeah, so we have to delete C first. Yeah, so that is C or B. And then now we're going to delete C. Yeah, just going to put there. So when deleting C, you have to calculate how many ways from A to D via C and A to E via B. Yeah? A to D via C and A to E via C. Okay, just check that again and I'm gonna ask somebody. Okay, Filbert Chakra, how many ways from A to D via C?
A to D. 12.
From
Oh.
A to D via C.
12. Oh.
Let's try another one. Cre Francisco Watulingas. Yeah. From A to D via C.
Where?
12.
Yeah.
Deborah Igir, how many?
Yes, sir.
How many? From A to D via C.
Formner.
4, 12. What is right now? What's the correct one? Yeah, so here there are 6 and here there are 2. So from here to here, there should be 12. Yeah. Now from A to E via C, how many ways? Ricky Mema. Ricky, are you there? Is Ricky there? No. Risky.
Yes, sir.
Yeah. From A to E via C. This one to there via this one. How many ways? Risky? How many ways? From A to E.
6, sir.
6. Yeah. So there are 6 ways from here. Oh, there's another color. Yeah. So now we are going to delete D. Now, how many ways from A to E via D? How many ways from A? Oh, let me ask first. How many ways now from A to D? Angel Tangkawaro,
Yes, Prof.
how many ways from A to D now?
4.
From A
4.
to D.
4.
4. Aurora Simajuntak,
Yes, sir.
yeah, how many ways from A to D?
15, sir.
How many?
15.
15. So they are parallel, okay? They are parallel, so you have to add them. Christina Tangka,
Yes, sir.
yeah. How many ways from A to D, to delta?
15, sir.
15. Oh. So there are 3 edges. They are parallel. So what you have to do with parallel edges? You have to add them. Yeah? Coba Kayla, Modeong.
Yes, sir.
From A to D, how many ways? How many ways?
3, sir.
3. Yeah, so here there are 12 ways, and here there are 2 ways, and here there's 1 way. So there's actually just 15 ways from here to here. Okay. $15 ways. Yeah. From D to E, there are 2 ways. Okay. So how many ways from A to E? Rifki Ramadan.
Yes, sir.
Yeah. From A to D, how many ways? 15. From D to E, there are 2 ways. So how many ways from A to E via D?
Uh, 30 ma'am.
30. Yeah, because
30.
yeah, 30. 30, right? Or 13. 30. Yeah, 30. So here they are 15 and they are 2. So you multiply them. Okay. So you have here, so they are 6. And then here, you have 30. Yeah, so now is easy. Eudemus, how many ways? Eudemus, Alom,
Yeah, Prof.
how many ways from A to E now?
Uh, was
From A to E, how many ways?
Abidjan.
Berapa? Eudemus?
12, Prof.
12. Coba. Lilian, Bulawan,
Yeah, sir.
how many ways from A to E?
30, 36.
Yeah. Okay, so this from A to E, they are 36 ways. Okay. Now you can screenshot now. This one. Okay, you can just screenshot. This one is live streaming to YouTube, so you can just watch it again. Yeah. Okay. Then we're just gonna continue with the video. Okay, now factorial. Factorial is defined like this. Yeah, so n factorial, so that is the symbol. Yeah, so n factorial, the symbol is the Dundas rule like this. So n like that. So that is defined as 1 times 2 times 3 and so on times n. Okay. And yeah, you can just write it from behind. Yeah. So n faculty equal to, yeah, so some people, yeah, in Netherlands they call it faculty. Yeah, n faculty. So factorials. Yeah. So n times n minus 1 times and so on times 4 times 3 times 2 times 1. Okay. So because the multiplication is commutative, so 4 faculty for factorials is 4 times 3 times 2 times 1. Yeah, so that's just normal multiplication, but you started from 1. Yeah. 3 factorials, that is 3 times 2 times 1, that is 6. And 2 factorial is, of course, 2 times 1. And that is 2. And 1 factorial is like that. Now, 0 factorial is, what is 0 factorial?
1, sir.
Yeah, so that's by definition. Yeah. But we're going to look at this is actually, so this is called recursively, yeah, n factorials equal to n times n minus 1 factorial. Okay. Because this whole thing is actually this one is just n factorial. Yeah. So factorial, 4 factorial is 4 times 3 minus 4 minus 1, that is 3 factorial. Yeah. So that's the same thing. That's 4 times 3 times 2 times 1. That's what you get. And 3 factorial is that. So it is recursively. Okay. So it is 1 factorial is according to this. So that is 1, if it is 1, then this should be 1, and this should be 1. Yeah. So if n is 1, then this n is also 1, then this one is also 1. So that's 1, you get 1, 1, 1. Okay. Now this is 0 factorial. Yeah, because 1 minus 1 is 0. And that is 1 times 1 factorial. Yeah, you see that? And that is the same as 1. Because 1 factorial is 1. So this one times 0 factorial is 1. So what is 0 factorial? Is of course 1. So that's how you prove that 0 factorial is 1. Okay. Now, so it is another thing. Okay, any question about the factorial? Okay, let's do. Okay, what is 5 factorial divided by 4 factorial?
Five, Prof.
Yeah. Okay, 6 factorial divided by 3 factorial.
Yeah. 120, sir.
Yeah, you can just calculate. That's easy, yeah. Yeah, for the in the exam, you don't have to compute. Yeah, you don't have to calculate. You can just, for example, say that 6 factorial divided by 3 factorial. That should be okay for me. Because everybody, yeah, unless I ask what is, for example, 4 factorial. What is 4 factorial? Then you have to answer that. Yeah. But if I ask something else, then this kind of form is already okay. Okay. So go to continue. Yeah. So 0 factorial equal to 1. So now, so we're gonna go to the combinatorics. So this is combinatorics. So they are actually just a basic concept of combinatorics, but now there are some fundamental things about combinatorics. Yeah. So suppose that you have 5 balls in the basket or in the can. Yeah. So they are labeled A, B, C, D, and E. And we're gonna take, for example, 3 of them. Okay, we're gonna take the ball, 3, and doing 1 by 1 and return. So if I take 1 ball, then I'm gonna put it back. Then I'm gonna take another one. I put it back in the container here. Then I take the third one. Then you can put it there. Yeah. So that's what it is. Yeah. So you take 1 ball. Then you note the ball. Yeah. For example, Then you take another one, put in the second place, then you put it back. You take the third one, put in the third place, then you put it back. Yeah. Okay. So this is an example. You can. Yeah. So when you take the first ball, how many possibilities are there? There are 5 possibilities because there are 5 balls inside. Okay. So for example, you take A. Then you note that. Ya, catat. Jadi bola pertama adalah A. So you note that. Then you put it back. The second withdraw, how many possibilities?
Four.
4.
Still 5, Mer.
Still 5. Yeah, because there are 5 balls inside. There are still 5 balls inside. Yeah, so not 4 but 5. Then you take another one for the second ball. Yeah, so there are 5 possibilities because there are 5 inside. Because you have put it back. Yeah. Now, for example, that you took B, then you note it, then you put it back. What's the possibilities of the third ball? Okay, you notice that when you take A, when you take the first ball, and that is A, then the second ball, that is B, that is totally different than when you take the first ball B and the second ball A. Yeah, so they are not the same. So AB and BA, they are not the same. Okay, so it means that the order, ya, urutan penarikan itu important. So the order is important. Yeah, so the order is important. Now, then you take the third ball. There are still 5 possibilities. Okay, when you take it, the third ball, the first ball was A. Now the question is, can you take A again for the third withdrawal? When you take for the third one, can you get the ball A? Yes or no?
Yes.
Yes, because it's inside here. You put it back, and so you can take it again. There's a chance that you take the ball A again. So but there are still 5 possibilities. Yeah. So what we notice here, that here you get A for the first withdrawal, then another A for the third withdrawal. So it means that they are repetition. Ya. Jadi ada pengulangan. A here and A there. Okay. So it's possible that the ball A, is it possible that you get A? Yes. Because there's a repetition. Because when you take the first one, you put it back. You take the second ball, you put it back. Okay? So it's possible that you can add the same ball. Yeah, so repetition, order, and repetition. Now, in general, if there are 5 ball. Yeah, so here, how many possibilities? So there are the first one is 5, the second one is 5, the third one is 5. Now, these 5, they are 5 parallel. 5 parallel possibilities of the ball to be taken. The second one is also 5. Yeah, so there are 5 possibilities for the ball. So they are parallel. The same way for the third withdrawal. So there are 5 parallel for the second one, 5 parallel for the third one. Now this one and that one and that one, they are in series. So what you have to do, you multiply them. 5 times 5 times 5. Yeah. So you multiply them, and so you get 5 to the power 3. Yeah, so you multiply them, then you get 5 to the power 3. Okay. So in general, yeah, so these 5 correspond to the 5 ball. Okay. And these 3 correspond to the number of withdrawal. Ya. Jadi ini 5 ini yang ada di bawah ini, the base itu banyaknya bola. Sedangkan 3 ini adalah banyaknya penarikan. Ya. So in general, if you have n balls and k withdrawal, how many possibilities are there? How many possibilities?
N to the power k.
Yeah, n to the power k. Okay? So that's n to the power k. Different sequence of withdrawal. So there are possibilities of withdrawal. Okay, any question about this? Okay, so here I can let's do this example. Oh, so this is better, yeah. So how many? Or maybe I'm gonna do this one, yeah. Okay, how many words can you make with letters A, B, C, and D? How many? Okay, how many 4-letter? Yeah, that's not. How many? So these are words, yeah. So any words, not Indonesian word. Yeah. So How many four-letter words can we make with letters A, B, C, and D?
24, sir.
24?
256, sir.
200?
256.
Yeah, so that's so this what I mean with in the exam, you don't have to tell the result like that. I wanna see rather that you do, for example, this to the power that, or this factorial. Yeah, so that's what I want, rather than you give 260 or 120. Okay, so what's the answer?
4 to the power 4.
4 to the power 4. Okay, so make it, maybe just make it clear so that they are going to be different. How about this? Put another one. Yeah. How many four-letter words can you make with letters A, B, C, D, E, and F?
1296 or 6.
Yeah, so that, you have to say that factorial or that to the power that, yeah, not the number like that.
6 to the power 6. 6 to the power 4. Sorry, sir.
6 to the power 4. Yeah? Everybody agree, or is there anybody has other solution, other answer? Yeah, so they are, yeah?
4 to the power 6.
Okay. 6 to the power 4 and 4 to the power 6. Okay, so which one is correct? Okay, let's take a look at this. Okay, so this is how you make sure which one is correct. So 4 letters, so that is 1, 2, 3, 4. Yeah, so there are 4 letters, 4 places, because these are the 4 letters. Yeah, and the first place, so this one, how many possibilities?
6, sir.
6, because you choose from these letters, so there are 6 of them. This one, the second place, how many possibilities?
Also 6, sir.
Also 6. The same way for the third one and the fourth one. And that's, you get, multiply them all, you get 6 to the power 4. Yeah? So it is a nice tool to make sure which one is correct. Okay, because I understand many students confuse which one is it. It's 6 to the power 4, 4 to the power 6. So you have to do something like this. Yeah. So there are 4 places, and each place there are 4 possible letters. Okay, is that clear? Or any question? Okay, let's do another one. Okay. How many 4-digit numbers?
Ten to the power of 10.
10 to the power
10.
10 to the power 10.
I mean 10 to the power 4.
10 to the power 4. Okay. Uh, so we have to agree with something first. Do we consider this as 4-digit number? So they are number. Do we consider as 4-digit or just 2-digit?
I think it depends, sir.
Yeah. Okay. So we just gonna do 2 ways. How many if something like this? Oh, if, yeah, so that is A. Okay. So for number A, we're gonna consider that, for example, 0012 is just 2-digit, because we don't count this 2-digit, 20-digit at the front. And then number B is anything, yeah. So we count 0012 is also 4-digit. So what's the answer for A? What's the answer for this?
For the A, I think so it's 9 times 10 to the power of 3. So there's 9,000. And for the B, if the 0012 is considered 4 digits, it should be 10 to the power 4.
Yeah. So this one is okay, yeah? So the answer is ten to the power 4. Okay, but for this, yeah. So it's always useful if you do something like this. So there are 2 places. You have to do this always, yeah? Yeah, for number B, so there are 10 possibilities. So why 10? Because the digit is from 0, 1, 2, 3, and so on until 9. Yeah, so there are 10 of them from 0 to 9. Okay, so here also 10, here also 10, and so they are 10 to the power 4. Yeah? Now this one is a little bit tricky, number A, because if you say for number A that so that is number B, yeah. So for number A here, if you say that here is only 9 possibilities, here is only 9, here is only 9, is only 9, yeah, that's not quite good. Because, for example, if you put 1 here, yeah, and here, for the second place, there are still 10 possibilities. This one is also 10 possibilities. This one is also 10 possibilities. Yeah? You understand what I mean?
Yes, I understand, sir.
Yeah, if you have non-zero here at the front, then for the second, the third, and the fourth places, can be anything. You can put 0 there too. Yeah. And here, for example, 0, 8, 0. It is okay. Yeah? Okay. Now you have to think that at home. So you discuss with your friend. Okay, we're going to continue with something else. Now the permutation. So that is very another important thing. So again, we have 5 balls. Then we're gonna take 3 of them. Yeah. But now the difference is that we, yeah, so you take, so this is important, yeah. You take 1 by 1, you take 1 by 1 and without return. Yeah. So the one before, you take 1 by 1 with return. Yeah. So 1, 1, 1 with return, and 1 by 1 without return. So, okay. Yeah, so you take 1 and you keep it. You don't return it. Don't put it back. Then you take the second one. You keep it. You don't put it back. Then you take the third one. Yeah. Now, when you take the first one, how many possibilities are there for the first place?
5.
5. Because there are 5 balls inside, yeah? So there are 5 possibilities. Okay? That is the first place. Okay? There are 5 balls inside, so there are 5 possibilities. Okay? When you take one out, you don't put it back. So for example, you take the ball A, you don't put it back. So the second ball, the second withdrawal, how many possibilities are there?
4.
4, yeah? Because there are only 4 balls inside. Okay. So for example, you take the ball B. Now, because you didn't put it back, for the third withdrawal, is it possible to get ball A or B?
No, sir.
It's not possible.
Not possible because there's no A and B inside here. They're already taken and you don't put it back. Yeah. So there's no, it's not possible to get A or B. And so here there are 3 possibilities. And again, here the order is important because when you take the first one is A and the second one is B, that is not the same as when you take B first and then A second. Yeah. So now the third one, third ball. Yeah, so the order is important. Yeah. The third ball, you cannot get A or B. So here there are 3 possibilities and repetition is not allowed. Yeah. So there's no repetition. You cannot have A or B here. So no repetition. Yeah. Okay. So then, for example, you have that E. And so that's 5 times 4 times 3. That is actually this one, 5 times 4 times 3 times 2 times 1. You recognize this. What is this?
120, sir.
No. The notation. Yeah. 5 times 4 times 3
60,
times 2. Yeah.
60.
Yeah. So again, I said I'm not so care about the result. How you solve actually.
5 factorial.
Yeah. So that's the answer. Yeah. 5 factorial. And this is, and so you have only these 3. Yeah. So this one is not there. That one is not there. So what you have to do is you divide it there. Yeah, so this is there, the same. Yeah. Then you get that. So this is 5 factorial divided by 2 factorial. Okay. So that is how you get that. That's 5 factorials divided by 2 factorial. Okay. So now this 2 is actually is this 5. So that is 5 is the same as that one. Is that 5? And this 3 is that 3. Yeah. So if you withdraw one ball with 3 withdrawal without repetition, and the order is important, then you have something like this. And that is how you calculate the permutation. Okay, n withdrawal, n balls, k withdrawal. It is the formula for general. So we call it P and K. So that is n factorial, n balls, divided by n minus k, k withdrawal. Yeah. Okay, so that is the formula for permutation. So this is the permutation. Yeah. Again, so that is the n, and the k is the withdrawal. So you're looking for n minus k, not k, yeah, but n minus k. Okay, the next one. Okay, so maybe we just gonna do some example for this. Okay, so what is if you have 4 person, okay? 4 person, so it is A, B, C, D. How many ways the order of this of these 4 person? So for example, they are doing like a competition, and every place there's only one. Then it could be this one is number 1, and C is number 2, and B is number 3, and number 4 is D. But it also could be the winner is D, the second place is A, the third place is C, and then the fourth place is B. So how many possibilities are there?
4 factorial.
4 factorial. Agree? So how you approach that problem? So there are 4 places here because there are 4 person. So there are 4 possibilities. Here there are 3 possibilities. It is 2 possibilities, and that is 1 possibility. Because if one person is already here, he cannot be here. So it is the first place. It cannot be the second place anymore, right? If the person is already the first and second place, it cannot be the third place anymore. So that's why there's only possibility here, and so on. So when you multiply this, then you get 4 factorial. Okay. Okay. Now suppose I have this 5%. Yeah. So how many possible winners, runner-up, and third place are they? So before, in the example before, we have 4 persons, and we are interested in 4 places. But here, there are 5 persons, but we are only interested in 3 places. This is the winner, the second place, and the third place. So how many possibilities?
4 times 4, 5 times 4 times 3.
Yeah, 5. So here there are 5 possibilities. Here there are 4 possibilities, and here there are 3 possibilities. And this is 4 to okay. Now, how about this one? Ten students join competition, but we need only the winners, runner-up, and third place. How many possibilities?
10 times 9 times 8.
Yeah. And in the using the permutation formula, how does the solution looks like?
4 factorial per 7 factorial.
4.
10 factorials
10 factorial.
dibagi
10 factorials
7
divided
factorials.
by 7 factorials.
Yeah. So here there are 3 places. The first one, there are 10 possibilities. The second one, there are 9. And the third one, there are 8. So that is, you multiply them. Yeah. So that is the same as 10 times 9 times 8, which is the same as 10 factorial divided by 7 factorial. Okay? So in the exam, I expect you to give this kind of answer. Yeah. So not calculate 10 times 9 times 8. If you give berapa ini? 720. Yeah. Yeah. I don't know where the 720 come from. If you have something like this, then it's clear. Okay? Okay. So we have just a little bit, maybe 10 more minutes. Yeah. So you have the permutation. So that's the formula. And now the combination. So we have again 5 balls. Okay, 5 balls. And 3 withdrawals, but we withdraw 3 balls at once. Yeah. So before we withdraw one by one, so we withdraw one, and then another one, and then another one. Yeah. The first one we return, the second one without return. Now we withdraw at once. So 3 balls at once. Okay. So the order is not important, yeah, because when we withdraw A, B, C at once, jadi satu kali tarik ya. Jadi itu order apakah A, B, C or B, C, A or C, A, B. You cannot say that because you take at once. Yeah. Because so the order is not important, and also no repetition because you withdraw at once and you don't put it back. Yeah. So order is not important. Repetition is not allowed. Yeah. So that's all. You get all or 3, yeah, at once. Okay. So it could be just these 3. So the order is not present is A, B, E or A, E, B. So that's not important. Yeah. So you have actually the same thing as the permutation. So that's P53. But now we don't care about the order. Okay. So how many possibilities of these 3 balls in random order? So how many of them? So here, so A, B, E could be. So you have to put, yeah, something like this. You have to put systematically. So here you have A first, and then you interchange the B and E. Here you have B first, then you interchange A and E. Here you have E first, and you interchange A and B. Okay, so there are 6 of them. Yeah. So you have to divide it. Okay. So that is 3 factorial. So the P53, that is this one. So 5 factorial divided by 3 minus 5 minus 3 factorial. So that is 2 factorial. Okay. Then you divide it, these 3. Okay, so that's what you get. Okay, so here it is. So we choose these 3, and these 2 balls are not chosen. Yeah, only these are selected, that are not selected. Then these are the possibility you interchange there, you move them to the thing, to the places, but it doesn't matter because there's not, so you consider these three as the same, and that's two as the same. So there are actually only two kind of ball here. The first one, there are three. The second one, there are two. Yeah, so there are these three that correspond to that three, and these two correspond with that two. The total is 5. Yeah. So if the order is not important and repetition is not allowed, then it is the formula. Now this one is easier. You don't be confused with the permutation because here you have 5 ball, 3 withdraw. You have that 5 here, and the 3 is there at the bottom, and also the remaining here. Ya. Jadi yang di permutation kadang-kadang orang salah. Jadi yang mereka taruh di bawah sini bukan 2 tetapi 3 ini. Nah, kalau ini tidak mungkin salah because you have 3 and 2 there at the bottom, okay, under the division. Okay, and so this has different name that is called the combination, and that is we have a special notation for that. That is the C53. Before we have for the permutation P53, and now we have this 3, 5, 3. Okay. And we have another notation for this one. Yeah, so that is in general, that is C and K, that is n factorial divided by k factorial divided by n minus k. And that is exactly the same as you interchange the bottom one, you're going to get n, Cn, n minus k. So that is the same. So that's symmetric. Yeah. So the Cnk the same as n. And it is a special notation for that. And we read it as n choose k. Okay. Any question? So next week, we're going to continue with some example with this one. And so it's okay, yeah? So it is important that you watch the video first so that you have idea which one you don't understand. Then when we have meeting like this, then you can ask question. Which one exactly you don't understand. Okay, any question?
I think there's no questions.
No question? Okay. Then see you next week. Don't forget the codes already posted in group, WhatsApp group. Okay.